please write down the problem. Construct ordinary and compensated demand functions. Construct ordinary and compensated demand functions for Q1. For Q1. For the utility function. For the utility function. U is equal to 2 Q1 Q2 plus Q2. Construct ordinary and compensated demand functions for Q1. For the utility function, U is equal to 2 Q1 Q2 plus Q2. Okay. So this is the problem. This is the problem. Okay. So let's start with this particular utility function. Okay, so please write down the utility function is given by U is equal to 2 Q1 Q2 plus Q2. Let the budget constraint is given by M is equal to 1 Q1 plus P2 Q2. This is the standard budget line. So, you know, if for some numerical exercise, the budget constraint is not given, we will consider or construct this budget line. And as you are understanding, M is the income and P1 and P2 are per unit prices of two commodities, Q1 and Q2. Next, the required Lagrangian expression. The required Lagrangian expression is given by L is equal to, what will be the Lagrangian expression, anyone?
2Q1 Q2 plus Q2 plus lambda into M minus P1 Q1 minus P2 Q2.
Very good. This is the required Lagrangian expression. Okay, if any student consider instead of this, this is also fine. Actually, in that case, you know, if you consider the minus sign here, so it should be P1 Q1 plus P2 Q2 minus M. So these two things are equivalent. You can do, or you can take any of the form. And here, as we understand, lambda is the Lagrange multiplier. Next, A4Cs, the first order conditions.
ম্যাম ল্যামডার সামনে সাইনটা ম্যাটার করবে কি?
কি বলছো?
ল্যামডার সামনে যে সাইনটা আছে, একটাতে প্লাস দিলেন পরেরটাতে মাইনাস দিলেন, ওটা ম্যাটার করবে কি?
ম্যাটার করছে কি, দুটো ইকুইভ্যালেন্ট নয়? তুমি প্লাস ল্যামডা দিলে দেখো ল্যামডা এম মাইনাস ল্যামডা P1 Q1 মাইনাস ল্যামডা P2 Q2, আর উপরেরটাতে মাইনাস ল্যামডা P1 Q1 মাইনাস ল্যামডা P2 Q2,
কিন্তু ব্র্যাকেটের মধ্যে জিনিসটা তো জিরো।
হ্যাঁ, ব্র্যাকেটের মধ্যে
তো জিনিসটা জিরো হবে।
তুমি আজকে প্রথম ক্লাসটা করছো কি?
না 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 করেছি।
হ্যাঁ, করেছো তো? কাজে কনস্ট্যান্টটা একপাশে নিয়ে এসে লেখা হয়, সেটা দেখেছো তো আগে?
লেফট সাইড, হ্যাঁ আচ্ছা, হ্যাঁ
সেটাই করা হচ্ছে, বুঝেছো? কনস্ট্যান্টটা ওভাবেই সেট করতে হয়, এন্টায়ার ম্যাটার লেফটে নিয়ে এসে ইকুয়াল টু 0 করে সেট করতে হয়। ওকে,
হ্যাঁ ম্যাম।
So del L by del Q1, del L by del Q2, del L by del lambda. So please derive all these three. I can give name L1, L2, L lambda. So what will be L1?
Ma'am, it will be 2Q2 minus lambda P1
Lambda
is equal
P1.
to 0.
Lambda P1.
2Q2 minus. Very good. What will be L2?
2Q1 plus
1 plus 1 plus minus P2 lambda.
2Q1 plus, yes, 1 minus lambda P2. And here this is equation number 1, 2, then what I'll do,
Ma'am, we'll equate 1 and 2 and get P2 by P1 equal to 2Q1 plus 1 by 2Q2. Then we
we
will
will
get
consider, there is little bit mistake, So please, dividing, please write down, dividing 1 by 2. Dividing 1 by 2, we get
yes, ma'am, I was telling this only.
okay.
Ma'am, we will take the value of Q2 and then we will substitute in 3.
So this can be also written as, and doing the thing, you can do in your own way as well. Yes. I think somebody told about this expression.
Yes, ma'am. I will substitute this in 3.
Yeah. Substituting Q2 in 3. So I'm combining actually 1 and 2, generating this equation, and then substituting equation 4 in equation 3.
ম্যাম ক্র্যামার্স রুল দিয়েও তো করা যেত।
হ্যাঁ হ্যাঁ করা যায়, এটা আমরা ক্লাসে বলে দিয়েছি যে আর যেভাবে খুশি করা যায়। Result is important. If somebody wants to do it using Cramer's rule, there is no problem. Whatever you like, you can do. Okay, so here I am doing, substituting. Please do that. You have to find out Q1 only, isn't it? What was the question?
Yes, ma'am. We have to only find it for Q1.
Okay, okay. So substitute and finally find the thing and check. whether you are getting this kind of expression.
Yes,
Solve
ma'am.
it. Okay. You are getting this expression 2a minus p1 by 4p1.
Yes, ma'am.
Yes, ma'am.
Very good. So this is the okay. Now actually, before telling that this is utility maximizing amount or the sentence I have written, this is the ordinary demand for Q1, we should check the second order condition. Okay, we should check the second order condition because of the size of this board is too small, the paint box only. So I am writing this. However, once I write Q1 is equal to this one, next we have to consider the bordered Hessian determinant. Okay. So we have to define the bordered Hessian determinant. Second order condition, we consider a lambda lambda. So okay, is it okay? We have to consider this.
Yes.
So next, we have to find out all these derivatives from 1, 2, and 3. Okay, so what is the value for L lambda lambda?
Ma'am, 0.
0.
What is the value for L lambda 1?
Minus
P1.
What is the value for this?
minus P2.
Minus P2. What is the value of, what is L11?
0.
Please,
Zero.
louder.
2.
2.
2. And finally, what is the value for L22?
0.
0.
0. So we have to substitute all these values in det H. So it is so derive the value.
Ma'am, 4 P1 P2.
4 P1 P2.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Ma'am.
So everybody please confirm whether you are getting this.
Yes, ma'am.
Yes, ma'am.
So everybody is getting this value 4 P1 P2. P1 and
Yes, ma'am.
positive, so it is positive. So Q1 star is equal to 2m minus P1 divided by 4P1. That is the utility maximizing amount. And this is presenting the ordinary demand for Q1. Okay, so we can add a star here. This is utility maximizing amount. Okay, so this first part is done. And in your home, you find out the demand for the other commodity, that is Q2 also, you will be able to derive and you can do the same. Okay, so rest of the things will be common, the second order condition, etc. So however, you will be able to derive the demand for Q2 as well, following the same procedure. So next, let's derive the compensated demand curve. So please write down. To derive the compensated demand curve, we minimize, to derive the compensated demand curve, we minimize the consumer's expenditure subject to utility constraint. Subject to utility constraint. Hence, the objective function is given by, what will be the objective function? What will be the objective function?
M equal to P1 x1 plus P2
M.
x2.
Yes.
M is equal to P1 Q1 plus P2 Q2. So what was the utility function? What was the utility function?
2
Ma'am,
Q1
2
Q2
Q1
plus Q2.
Q2 plus Q2.
Okay. So we minimize subject to the required then what will happen?
Plus lambda.
Plus,
Uh,
I am using another notation because this is the same problem. Mu, say mu,
yeah, within bracket u star minus 2q1 q2 minus 2q2.
is it fine? Or you can write minus mu, then 2q1 q2 plus q2 minus u bar. So any way you like. The constant minus the variable part or the variable minus the constant part. In that case, you have to consider minus of mu. Next, FOCs. So tell me the values.
Ma'am, first one is P1 plus mu2 Q2.
Just a minute. P1 minus
2 mu Q2.
2 mu Q2 is equal to 0. The second is
P2 minus
2 mu q1 minus 2 mu.
minus
2 mu.
2 mu or mu only.
Mu. Mu.
Only mu.
Yeah. Yes, I'm only mu, sorry.
Okay. Dividing 1 by 2. Dividing 1 by 2. We get
ম্যাম ফার্স্ট অর্ডার কন্ডিশনে লাস্টেরটা জেড যেটা লিখেছেন জেড মিউ হবে না মানে মিউ দিয়ে ডেরিভেটিভ
হ্যাঁ মিউ ঠিক বলেছো ঠিক ডেফিনেটলি Thank you. Now it's okay?
ইয়েস ম্যাম
Here you can cancel mu. So the equation reduces to this one. Okay. Or you can write Q2, you can go one step further and from here Just please check. I think it's all right. Q2 is equal to this one.
Yes.
Yes, ma'am.
Substituting Q2 in equation number 3. Substitute Q2 in equation number 3. And derive the value of Q1. Tell me the value once you get it. There will be, I think, a square root. Those who are willing to do it using Cramer's rule, no problem. Please do so. Once you get the value, please let me know. Once you get the value, please let me know.
And will it be a middle term? Not middle term, sorry. Shridharacharya has to be used.
Please tell me the value. Let me write it.
Yes, and just a second.
Ma'am, it's u bar into 2p2 is equal to
Q square, Q1 square plus Q1 plus 1.
yeah.
Okay, so please check whether you are telling this thing. Q u bar P2 by P1. Are you getting this value? Whole divided by 2.
Yes, ma'am.
Yes, ma'am.
After Shridharacharya, this is the.
Yes, ma'am.
Are you getting this one?
Yes, ma'am.
Okay. So rest of the students, please confirm. So now move towards the second order condition. Z mu mu. So all the students are getting this value.
Yes, ma'am.
Good.
Yes, ma'am.
So one by one, please derive Z mu mu etc. and tell me about this value. So what is the value of Z mu mu?
0,
0.
তারপরে 1 1 ও 0, 2 2 ও 0,
এটা কি হবে?
2 Q2,
মাইনাস না?
হ্যাঁ ম্যাম -2 Q2।
আমারটাতে না।
মাইনাস হচ্ছে তো। এটা কত হলো? Z11
0,
12
-2 mu,
very good.
এটাও 0।
Yes.
তারপরে আসবে is equal to 4 into Q1, 4 into Q2 mu, আর ব্র্যাকেটে Q1 plus 2 Q1 plus 1।
4 হচ্ছে না 8 into?
হ্যাঁ 8 হচ্ছে, অ্যাড হচ্ছে।
8 হচ্ছে না?
হ্যাঁ।
এইটা
মাইনাস হচ্ছে না ম্যাম,
মাইনাস আসছে না?
না তো।
অন্যরা একটু দেখুন। আমার তো মাইনাস আসছে। মাইনাস না এলে তো সর্বনাশ। মাইনাস না এলে তো হবে না, মিনিমাম হবে না তো।
Yes, ma'am, minus is coming.
Minus is coming or not coming?
It is, ma'am.
Awesome.
Okay. So please check this thing. তোমার ফার্স্ট টার্মটা মানে যেটা জিরোর পরে তো -2Q2 ছিল, সো এটা হবে ইকুয়াল টু 2Q2 মাইনাস অফ মাইনাস প্লাস হয়ে যাচ্ছিল, and within bracket -2 mu into 2Q1 plus 1.
হ্যাঁ ম্যাম, কারেক্ট করে নিয়েছি।
হ্যাঁ, সব টার্মস গুলো দেখো ইন্ডিভিজুয়ালি মাইনাস আসছে। Every term is coming with a minus sign. Since mod h bar or bordered Hessian determinant is negative, Q1 star is expenditure minimizing amount of commodity. It is minimizing the expenditure. Okay, so this is minimizing the expenditure. So it is Q1 star. Subject to it is the compensated demand for Q1. If capital Q1 is the commodity, small q's indicate the quantities of the commodity. So it is the compensated demand. If anyone have any problem, any query, any question, not getting these values, please let me know. So in this way, we will be able to derive the ordinary demand, compensated demand for the commodities. Okay. So I hope everybody has the exercises from Henderson and Quant now. So let's please open that page. So you will be able to complete 2.1. Determine whether the following utility functions are regular, strictly quasi-concave for the domain Q1 greater than 0, Q2 greater than 0. And then there are several utility functions. U is equal to Q1 into Q2. U is equal to Q1 to the power gamma into Q2. U is equal to Q1 square plus Q2 square, etc. So do all these exercises. Please check whether the utility function is strict quasi-concave here. Okay? Already in the class, I discussed how to check quasi-concavity, or it will be better if I discuss one numerical exercise. Anyone need it?
হ্যাঁ ম্যাম একটা করিয়ে দিন।
Okay. Just a minute. যে কোনো একটা নাও আছে, যে কোনো একটা নাও, এটা নাও। দেখো, U is equal to Q1 square plus Q2 square. Okay. Then you find out F1. এই স্লাইডটা সবার হয়ে গিয়েছে করা? U is equal to Q1 square plus Q2 square. What is del U by del Q1?
2Q1.
And this is?
2Q2.
2Q2.
What is F12?
0.
0.
Yes. Very good. What is F11?
2.
2.
And what is F22?
2.
2.
Okay. Now please write down the strict quasi-concavity requires. The strict quasi-concavity requires sorry. What will be the sign? Greater than 0 or less than 0?
Less than 0.
No.
Greater than 0. In this
Like the
position,
Greater.
determinant value will be less than 0, and then we take the negative, so then it will be positive.
Positive, yes. So here we are talking about the condition, so directly we will write it to be greater than 0. We are mentioning that strict quasi-concavity. So you can start with the determinant as Kritika is telling, and then you can come to this condition, or directly you will use this condition. Strict already
Yes, ma'am.
are there in the slide, and I think you did all these things in your first semester course too. Okay, so put the values in the expression already. F11, F22, F1, F2, everything is with you. And, put all these values there and check what is the sign. So put the values there and tell me what is the sign. So for this particular problem, find out this value. F12 is 0. The first term is.
and it is not. It is not strict.
It is.
Not. This is minus
You are getting minus sign. You are getting is this to be less than 0.
Yes,
Yes, ma'am.
Yes,
No, no.
ma'am.
Yes, ma'am.
What is the value? What is the value?
minus 8 q2 square
Minus 1.
Plus Q1
Minus
square.
8.
q2 square.
Minus 8 Q1 square.
Yes, ma'am.
Minus 8 Q1 square.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Minus
ma'am.
8 or minus 4? Minus 8.
Minus 8.
Minus 8.
Okay. So this is hence the utility okay. So in this way you have to check for all the problems, all the numerical things given there. So 2.1 I hope done. Then 2.3, find the optimum commodity purchases for consumer whose utility function and budget constraints are U is equal to Q1 to the power 1.5 Q2. This is the utility function, and the budget constraint is given by 3 Q1 plus 4 Q2 is equal to 100. So budget constraint is given, utility function is given. So I hope you will be able to find out Q1 and Q2. Then consider
Yes, ma'am. Lagrange.
হ্যাঁ বলো কিছু বলছো?
Ma'am, Lagrange.
Yeah.
Direct.
Yeah, you have to consider the Lagrangian expression. You have to derive the FOCs. You have to divide equation 1 by equation 2. You will get equation to the ICC. Then you have to solve it with the budget constraint and you will get the optimum amount. So did you complete this exercise? Is there anyone who completed this one? আচ্ছা এটা কি পারা যাবে, করতে পারবে তো এগুলো নিউমেরিক্যাল এক্সারসাইজ ঠিক যেভাবে করলাম আমরা কম্পেনসেটেড ডিমান্ড অর্ডিনারি ডিমান্ড ওইভাবে করতে হবে, ঠিক আছে? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
সবাই পারবে তো?
ম্যাম
তাহলে করে ফেলবে এটা। নেক্সট হবে তোমার দেখি 2.4, the locus of points of tangency between income lines and indifference curves for given prices P1, P2 and a changing value of income is called the income expansion line or the angel curve. Okay, ICC, what we learned as income consumption curve. Show that the angel curve is a straight line if the utility function is given by u is equal to q1 to the power gamma q2. So utility function is given, you have to find out the equation to the ICC. Here they are considering an equivalence between the income consumption curve and the angel curve. Actually, what we do in case of income consumption curve, we consider a two commodity world, whereas in case of angel curve, we consider income and commodity space. However, the way the problem has been presented, actually you need to find out the income consumption line, and that will itself will work as the equation to the angel curve. So any idea how we will do 2.4? Prithviraj, how to 2.4? Prithviraj?
We will consider the relation between two commodities after first order conditions using Lagrange.
পরিষ্কার করে বুঝতে পারলাম না, ধরো এই ইউটিলিটি ফাংশনটা আছে, কি কি স্টেপ করবে একদম প্রথম থেকে বলো। দিস ইউটিলিটি ফাংশন ইজ গিভেন, তো কি করে কি কি স্টেপস হবে আমরা সবাই বুঝতে চাইছি।
ফার্স্ট কমোডিটির রেসপেক্টে ডিফারেন্সিয়েট করব, তারপর সেকেন্ড কমোডিটির রেসপেক্টে ডিফারেন্সিয়েট করব।
ডিফারেন্সিয়েট করবার আগে একটা লাগরেঞ্জ সেট করতে হবে।
লাগরেঞ্জ, यस ম্যাম, আই টোল্ড।
ও শুধু শুনতে পেলাম না তো আমরা। তাহলে একটা বাজেট কনস্ট্রেন্ট করবে। First you have to write a budget constraint. Utility function is given. You have to write for the budget constraint. Then you have to set the Lagrange, and then you have to consider the
first order conditions.
Yes, combining 1 and 2 or
and
dividing.
Then from the equation 1 and 2 and dividing, then we'll get the expansion path. That's ICC.
Get this income expansion path, and then you need to check what is the form of this expansion path. What will be the standard format of any equation passing through origin?
Y is equal to mx.
Y is equal to mx. Very good. So it will be of the form y is equal to mx, where m is the gradient of the equation. Okay, the standard format is y is equal to mx plus c. Okay, the straight line is y is equal to mx plus c, where c is the intercept or the constant present in the equation. So here we need a straight line passing through origin, so it will be of the form y is equal to mx. So please do this thing. Okay, next. Okay, so the equation, problem 2.5. Show that the utility function u is equal to a q1 to the power alpha, q2 to the power beta, and w is equal to q1 to the power alpha by beta into q2 are monotonic transformations of each other. U is equal to a q1 to the power alpha, q2 to the power beta, and w is equal to q1 to the power alpha by beta q2. We have to show that two expressions are monotonic transformation of each other. So using these mechanism, we learned how we will do this thing. Any idea? Oyon? Oyon is not here.
Ma'am, if we can show that MRS is same or
একটু ভালো করে বলো, বোঝা যাচ্ছে না, একটু ভালো করে বলো।
ma'am, if we show that the ratio of marginal utilities is remains the same, then we can say that they are monotonic transformation because the slope of the ICs has not changed.
Yes, আর এখন যে টেকনিক শিখলে সেটা দিয়ে কিভাবে করা যাবে?
If the demand curve if the demand function remains same.
Yes, so আমরা যেটা করতে পারি, we can consider a budget line, of standard format. Using two utility functions, we can set the Lagrangian expression and we can solve for Q1 star and Q2 star. If we find the same values for Q1 star and Q2 star, solve using two different utility functions, in that case we will consider one is monotonic transformation of the other. Okay, one is monotonic transformation of other. So what Oyon is telling, that is also right. If you consider only the first equation, if you don't solve for Q1 star and Q2 star, if you consider the equation number 4, when you are dividing 1 by 2, that equation, that is MRS is equal to PX by PY, that equation, or equation of income expansion path. And if that income expansion path is identical for two utility functions, in that case, they are monotonic transformation of each other. Because the other equation, that is equation number 3, that is the budget constraint, which is similar. So if you solve two similar equations, naturally you will get the same result. So it is not necessary to find out Q1, Q2, solve for Q1, Q2. Once you get equation number 4, or once you get the income expansion path, and if you find that equation to the income expansion path is identical between the two contexts, naturally solving this with the budget constraint or equation number 3, you will get the same result. So you will be able to write down this thing. So what will be your task? Set Lagrangian expression and derive the first order conditions, and then find out the income expansion path for the two different utility functions and check whether they are identical or not. Problem number 2.6. Let a consumer's utility function be U is equal to Q1 to the power 6, Q2 to the power 4 plus 1.5 log Q1 plus log Q2, natural log, ln Q1 plus ln Q2. And the budget constraint is 3Q1 plus 4Q2 is equal to 100. You will find that in problem number 2.3 and 2.6, the budget constraints are identical. Problem number 2.3 and 2.6, budget constraints are identical. Utility functions look different. In 2.3, the utility function is given by Q1 to the power 1.5 Q2, whereas in 2.6, it is given by U is equal to Q1 to the power 6, Q2 to the power 4, plus 1.5 ln Q1 plus ln Q2. Okay, show that this optimum commodity bundle is the same as in exercise 2.3. Why is this the case? So you are considering two different utility functions, however, the same budget line, and in 2.3, whatever amounts you are getting solving all first order conditions, the same amount you will get in equation number 6. Okay, the question is why you are getting the identical amount. What can be the answer? To different
monotonic transformation.
Monotonic transformation.
The utility functions are monotonic transformation.
Yes, that will be the answer. Okay, so one utility function is definitely then monotonic transformation to the other. Okay, so 2.6 done. Achha, 2.7 already done in the class. Construct ordinary and compensated demand functions for capital Q1 for the utility function U is equal to 2Q1 plus Q2 plus Q2. This is done in the class. Okay. So do these problems, do these problems, that is up to 2.7. Okay. And in 2.7, you will find that
2.8 and 2.8, can you tell me how to do that?
I'm telling you to solve up to 2.7, and why you are asking for 2.8?
Sorry.
Leisure kind of thing you have in your micro course later. Okay, so first you need to know the label leisure framework, and then only you will be able to do 2.8, not now. Okay, so label leisure is there in other semester. So when you will learn the micro theory, only then you will be able to solve it. Otherwise, I have to discuss the model behind this. Okay, label leisure framework. That is also constraint optimization. Constraint will be the 24 hours time. So that is a different framework. So you have to solve, up to 2.7. For these mathematical course, please solve up to 2.7. So complete all these things. Okay, complete all these things. And then it will be easy to understand what is happening, etc. So now I'll shift to, do anyone have any question regarding utility maximization, expenditure minimization? Anyone, any question? Okay, so in your last semester in mathematical economics course, I think you did or you solved the exercises based on homogeneous function. So everyone have idea about the homogeneous function, homothetic function?
Yes, ma'am.
Yes, ma'am.
Okay. So, so if demand is homogeneous of degree 0 in prices and income, prove that sum of own price, cross price, and income elasticities is equal to 0. This you did in your last semester?
Yes, ma'am.
Yes, ma'am.
Okay, so add this kind of thing also for this semester course, because all these things are included. When you are deriving the demand function, here you learned how to derive the demand, ordinary demand, compensated demand using the Lagrangian technique. Now, once you derive the demand function, all these issues are appearing. Show that demand is homogeneous of degree 0. Okay, so you are solving the equations, then these parts are coming. Show that demand is homogeneous of degree 0. The exercise today I discussed, for that you need to check whether demand is homogeneous of degree 0 or not. Okay, so we will come to that. We will come to that. So all these kind of exercises are included. Are you familiar with the derivation of Slutsky equation? When you did the Kremes rule, did you do this thing? Derivation of Slutsky equation in a 2 commodity world or n commodity world, did you do this thing in that part of the mathematical economics course this semester?
No, ma'am.
No, ma'am.
No, ma'am.
Slutsky equation you didn't do. Okay, okay. In the Kremes rule section, you didn't do it. Okay. So first, let me discuss one issue relating to which is related to the idea of demand is homogeneous of degree 0, then I'll move towards Slutsky equation. Okay, so please write down a question. An individual lives in a two-commodity world. An individual lives in a two-commodity world. How will his purchases change if prices and income, if prices and money income are doubled?
Mom, can you repeat, please?
An individual lives in a two-commodity world. How will his purchases change if prices and money income are doubled? Prices and money income are doubled.
Ma'am, will they remain same because it gets striked out? Purchasing power is the same ultimately.
Yes, you have to prove this, that if the money income and all prices are doubled, in that case, consumption will remain unchanged. Okay, consumption will remain unchanged. Yes, you have to show that. And this is called the absence of money illusion. And this is similar to the fact that demand is homogeneous of degree 0. If we increase the prices and income, all the parameters in the demand function by the same amount, the demand will remain unchanged. In other way, actually, we are telling that demand is homogeneous of degree 0. Actually, when we prove demand is homogeneous of degree 0, actually we prove this statement. If money income, prices, all these things are increased by the same amount, then the demand will remain unchanged. You did it in the last semester. This is the meaning of homogeneous of degree 0. Is it okay?
Yes, ma'am.
What the rest of the students are doing? Are you familiar with these things? Demand is homogeneous of
Yes,
degree 0
ma'am. Yes, ma'am.
and income.
Yes, ma'am.
Okay, then you use the Euler's theorem, derive the relation between the elasticities, etc. So the same thing here we are discussing. Just what we are doing, we using the Lagrangian expression and doing the things. So please write down, let the utility function be. So just we are revising the things. We are not doing new things. Let the utility function be u is equal to f of q1, q2. And the budget constraint is given by this. Okay? And you are understanding the notations of Q1, the meaning of the notations Q1, Q2, P1, P2, aim, etc. Aim is the money income. Okay, it's not the real income. It is money income of the consumer. So consumer wants to maximize this subject to this constraint. The required Lagrangian expression is given by Okay. Then we consider the first order conditions. This is F1 minus lambda P1. This is F2 minus lambda P2. And this is dividing 1 by 2. Okay, so this is the equation to the income consumption curve. Solving 3 and 4, we get demand functions in terms of the parameters M, P1 and P2. Okay. Okay. Next, let okay, in this okay, so equation 4, when both the prices uh, increased by the double amount, this equation remains unchanged. So this equation also remains unchanged, you know. So if you solve for two unchanged equations, that is you will get the same amounts. You will get the same amounts of Q1 and Q2. If we solve for two unchanged equations, we will get the same amount of Q1 and Q2. Hence, when money income and prices, everything increase by the same amount, there will be no change in quantity demanded. Okay, there will be no change in quantity demanded when all the money income and prices changes by the same amount. It doubles, or it is reduced by the same amount 3 times, everything. If all the parameters increase by the same amount, there will be no change in demand. Please note down, this is called the absence of money illusion. This is called the absence of money illusion. And this is equivalent to the notion of demand is homogeneous of degree 0 in prices and income. Demand is homogeneous of degree 0 in prices and income. So is it okay? Is there any question? Once we understand this part, then we solve for this exercise, If demand is homogeneous of degree 0 in prices and income, prove that sum of own price, cross price, and income elasticities is equal to 0. Okay, so first, using the Lagrangian expression, we derive the demand. Then we show that demand is homogeneous of degree 0. Then we show that sum of these elasticities is equal to 0. Is it okay to all of you? Any question? Anyone? Any question? Okay, so next. Next, we will come to the idea of Slutsky equation. Okay, we will come to the idea of Slutsky equation. So this concept we did in our micro class. Can you remember this slide? Can you remember this relation?
Yes, ma'am.
We did this relation, okay? We mentioned that here we are presenting the concept of Slutsky equation, and actually we have to prove this. We have to prove this kind of relation we have to prove. Okay, so this relation we can prove using the Kremas rule. So first I'll do it using a 2x2 framework, 2 commodity world, and then we can extend the concept for the n commodity world. So today, if I tell you about this thing, will it be feasible, or I should do it in the next class?
Next class.
Yes, ma'am. Next class.
So for the majority, I'll do it in the next class, or it's comfortable?
Ma'am, next class would be better.
Next class will be better. Okay, so please check the thing, please check the concept, complete all the exercises, numerical things, if any, including the second order conditions, not only the first order condition, do all the exercises based on utility maximization and expenditure minimization, all the exercises, I mentioned. And if some other problems also you like to solve, you can check Chiang, you can check the micro book, some problems will be there. It's not necessary to solve 50 problems based on a particular topic. It is more important to solve new varieties, at this level. So whatever you want to do, please complete all the things based on utility maximization and expenditure minimization apart from Slutsky equation. So next class, I'll talk about the Slutsky equation, and then I'll switch to cost minimization and output maximization problem, okay? Because that part is also a huge part. Okay then,